Hello again, Tom from Every Step Calculus, everystepphysics.com. This is a partial fraction decomposition problem. The reason is because this factors to x plus 1 and x plus 2. Anytime you can factor the denominator, you have to use partial fraction. If this x squared here was the same as x squared here, you'd have to do short division, and then what happens is you just add a 1 at the end before you integrate, and of course integrate a number by the respect to x and you just get x at the end, so you have to add a plus x at the end. But everything's the same because 1 times this divisor is the same. But this one is long division because it has more than 1 between the order of exponents here. So it's pretty complicated, kind of complicated, and certainly complicated if you're not studying it like me every day for hours and stuff like that. But for you, yeah, it's going to be not easy to pick up right away, but you can do it. Index 8, to get to my menu, you buy my programs, and then I show you how to put index 8 in here. This shows in the open and close parentheses show you that you want to do a program. And with index 8 goes right to my main menu, which is about 180 or so subjects, all related to calculus. If you buy the physics programs, they're all related to physics. And you click on what you need. For instance, this would be partial fraction, so you just go down to the menu and click on partial fraction. Let's do it. I'm already at partial fraction because I've done so many of these, but you're scrolling up or down to get to here with the cloverleaf. And there's partial fractions. This tells me I'm at the program. And we're going to enter the integral. You have to, in any of my programs, you have to add a alpha. Right here, alpha. You have to press this for second alpha first, just once, and then you can add the terms of the problem. I've already done that because sometimes this simulator messes up if you go through that, and then you have to start from the beginning and shut the video down, etc. So I've already done that. But you'd press second, and then you'd put x to the 4. Here's x to the 4, plus 2 times x plus 7. And of course, you like to add parentheses if this is the numerator, so you don't have to add parentheses here. But denominators, you always should add parentheses. And then after you've entered all this, I give you a chance to change it in case you've made a mistake, but I say it's okay, so then you can move on. I factor the denominator for you, the calculator does, x plus 1 plus x plus times x plus 2. And because the numerator has an exponent that is higher in order than the exponent in the denominator, long division is required. So I show you how to do long division. Here we are, here divided by x4, 2x plus 7. First you divide, the x plus 4 by x plus 2, which gives you x squared. That's quotient number 1. Second, multiply the quotient number 1 by the divisor and subtract. Here we are, here's the divisor. Here's the dividend here, and then you multiply the quotient number 1 times the divisor. You come up with you have to add these zeros to make sure that everything's complete, like x4, x3, x2, x1, and 7, or whatever's missing. You have to add that, which I do automatically in the program. It took me about a month to program this, not bad. Get it all correct. Third, then what you just found is you minus x cubed divided by x squared is equal to minus 3x. That's quotient 2. You just write this stuff on your paper, keep writing it down, and you'll get figured out. So here's the total quotient, now x squared plus a minus 3x, okay? Fourth, multiply quotient 2 by the divisor and subtract, okay? Here's a divisor, and we're going to multiply it times 2. We get this here. Subtract it from what we obtained before. We get 7 squared plus 8x plus 7. Fifth, 7x squared divided by x squared is equal to 7. Okay, so that's quotient number 3. Total quotients are now x squared plus minus 3x plus 7. Multiply the quotient number 3 by the divisor and subtract. Here we did this again. Same system. We come up with 13x minus 7. Minus 13x. Now the answer is because when you can't x4 in the divisor, you can't divide it anymore into the remainders of what you've attained by subtraction. Then you're finished. So this is the remainder. Here's the answer, x squared minus 3x plus 7, and here's the remainder over x squared plus 3x plus 7, which is the original divisor. And now we're going to set up the problem. So here's minus 3x minus 7 divided by x squared plus 3x plus 2, and here we multiply that times here, just on the left side of the equation, and equals a over x plus 1 and b over x plus 2. And then times x plus 1 times x plus 2. So we're multiplying, trying to get rid of the denominators, trying to make it linear. That simplifies to minus 3x minus 7 equals a times x plus 2, b times x plus 1. Notice how these reverse, because when you multiply times x plus 1 plus x plus 2, then you get the other ones, the x plus 1 cancels, and you get x plus 2 here. Same thing with the b. Now at x equals minus 1, to cancel the b term, we're going to enter it here. The quotation marks are what you're entering. Here's your minus 1 here. Here's your minus 1 for a plus 2, and here's b canceled because minus 1 plus 1 is 0. So we're canceling the b. And then I show you a plus, a times 1, plus b times 0, of course, it's 0. You're going to have 6 on the other side. That's what that turns out to be when you put a minus 1 in there. And so a is equal to 6. Minus 2, we cancel the a term. Minus 13x minus 2 minus 7 turns out to be 6 again. Or what? No, it turns out to be 9, I think, minus 9. A times, here we're canceling the a, minus 2 plus 2. And here's the b term. So 19 equals a times 0. B times a minus 1, so b is equal to minus 19. You bring that back to and substitute those for a and b into the original partials. A was x over 1 and b was x over 2, right? So we have 6 minus 19 over x over 2. So the integrals turn out to be x squared minus 3x plus 7, which is what we got in the long division answer, times the integral of 6 over x plus 1 dx over the integral of minus 19 x plus 2 dx. When we integrate that, we get x to the third power over 3 minus 3x to the second power over 2 plus 7x, and then 6 times log of x plus 2 and minus 19 log of x plus 2 plus c. Pretty neat, huh? EveryStepCalculus.com. Go to my site, Pass Calculus. If you can use the calculator, use it in your class, And if you can't, you're still going to learn about calculus, that's for sure. Doing these problems, you can do a million of them. It's amazing how this program works. So I'm still thrilled at the program, and it's just amazing what MIT did to invent these the way this calculator can do these programs. 30 years ago, I was the first one, or first in class to get these I got a TI-92 Plus calculator, which in those days we had to buy for $285. I was bugged about that at the time to pass, and they showed you how to do integrals and calculator and derivatives on the calculator, and I says, oh my God, that's great, But during a test, you couldn't. If you just put down the answer, you got it wrong. So you had to put down the steps like we do. So then I invented, and I'm the only one in the world that does this, invented the step-by-step process of all problems, doing it step-by-step. In physics, everything else, I programmed thousands of programs. Lasers, concave mirrors, convex mirrors, electronic circuits, even now, I'm in San Diego and I go get my gas in Tijuana, which is $3.75. So I go to get their gas there, and of course they deal in pesos and they deal in liters, and of course they exchange money too, for pesos. So I wrote a program for that, so I know exactly how much gas costs in Tijuana. You can program anything. If you can put it on paper, you can program it. And all these problems I have to put on paper to first to figure it out, and then I can program it all into the calculator. So anyways, I'll help you all I can. You can call me. I'll help you in your calculus, or I'll help you how to use the programs, or if something it doesn't work, then I'll reprogram it for you or whatever. So pretty good deal. Don't ever throw out the calculator. You can throw out your calculus book, get rid of that one, and physics book, never use it again, but don't get rid of the calculator once you buy it, because your partners may use it in the future to upgrade their degrees in business and stuff like that. And then you might have grandkids, you might have kids of your own that need to know how to do calculus. And here it's all in this calculator right here. So have a good one. Good luck on your classes, okay?